All right, in this example, we're asked to evaluate that integral. So that means I want to try and find a value for it. Looking at this, it seems to me that it's going to be integration by parts. So I'm going to let my u be x. That means du will be dx. And dv, e to the negative x. So v, when I integrate this, negative e to the negative x. Therefore, this integral is going to become uv evaluated from these bounds. But since I have an infinity, I need to make it into a limit. So I'm going to say limit as b goes to infinity, and then I'm going to evaluate my uv. So negative x e to the negative x. That's going to be evaluated from a to b, minus the integral of v du. Since I've got a negative here, minus a negative is going to turn into plus. Again, I've got my limit as b goes to infinity, integral a to b of e to the negative x dx v du. So now, evaluating this limit, I'll have the limit as b goes to infinity. Replacing b for my x's, I'll have negative b over, because of the negative exponent, e to the b, minus negative a e to the negative a, plus, when I integrate, I'll get negative e to the negative x again, evaluated from a to b. Need my limit in there. All right, so looking at this limit, if I plug in my infinity, I have infinity over infinity, which I don't know how to evaluate. We're going to learn that very soon to evaluate it with L'Hopital's rule. So instead, I'm just going to think about what's happening here logically. So the rate at which b versus e to the b grows, well, e to the b grows significantly faster than b. So even as I go towards infinity and have infinity over infinity, this value is going to be much larger than this one. So if I think about like b being 100, I have 100 over e to the 100. E to the 100 is way bigger than 100. So this limit is going to go to 0. Similarly here, I'm going to have negative 1 over e to the b. That is definitely going to be 0, minus negative e to the negative a. So that's going to turn into plus e to the a. So this one just comes down. I'll have 0 from my first limit, and then e to the negative a. Again, this plus is because I subtracted a negative. So in the end, that means my whole integral a to infinity of x e to the negative x dx is equal to a e to the negative a plus e to the negative a.